Hi everyone, it's Miss Costa here, and in this video we're going to be going through how to rationalise the denominator of a surd. Okay, so here I've got a question that is asking me to rationalise the denominator of 3 over root 7. Now all rationalise means is write it in a rational number. So rational numbers are things that are not recurring decimals. So square root of 7, if you type that into your calculator, you'd get a really long decimal number. So rationalise the denominator basically means no surds on the denominator. Okay, so that's what we're trying to do. So to rationalise something, what I can do, because I know that a surd multiplied by itself gives me a whole number. So like with the square root of 25 times the square root of 25, that would give me, well, 5 times 5 is 25. So similarly, the square root of 5, which is 5, times the square root of 25, which is 5, is going to be 25. So anytime you multiply a surd by itself, it becomes its unsurded self. So if I did the square root of 7 times the square root of 7, that would give me 7. Okay, so that's a really key point. So what I can do in order to rationalise the denominator, I just multiply the whole fraction by the denominator if this is a single surd on the denominator. So for now, let's just stick with that. So I'm just going to multiply everything by root 7. And the reason I do this is because I have to keep the fraction equivalent. So if I just multiplied the denominator by root 7, that would change the value of the fraction. Like if you had 2 quarters multiplied by, let's say 3 over 3, that would become 6 over 12, which simplified becomes 2 quarters or a half ultimately. So that's why we multiply by the same thing on the numerator and the denominator, because we're keeping the fraction in equal value. So what do? I just multiply across. So that would become 3 root 7 over 7. And that's all I do to rationalise the denominator. So let's try another question. This is a slightly bit trickier because it's got a surd on the top, but don't panic. So we've got root 5 times by root 7, and I want to rationalise the denominator. So therefore, I'm going to multiply by whatever's on the denominator. And then I want to write my answer in the form root a over b. All that means is I'm not going to be able to rationalise the numerator, but that doesn't matter. So let's multiply it once again by root 7. So that would become root 5 times root 7 would be root 35. And root 7 times root 7 would be 7. So root 35, if I tried to simplify that, I can't simplify that any further. So I leave it as it is. It's in the form root a over b, and that's all you've got to do. So now let's have a go at trying these out for yourself. So just pause the video and let's see how we get on. Okay, so what do I do for the first one? I'm just going to multiply by the denominator. So in this case, it's root 8. So that would become 2 root 8 over 8. Now, when you rationalise, you also want to simplify it. In general, in life, in maths, you always want to simplify it if you can. So root 8, I know that could be written as root 4 times root 2, which is 2 root 2. So therefore, that would become 2 times by 2 root 2. So that would become 2 times 2 is 4 root 2 over 8. So that's for your first one. That would become 4 root 2 over 8. Now let's try the next one. So we've got root 2 over root 5. To rationalise the denominator, I always multiply both the top and the bottom of the fraction by the denominator. So multiply by root 5 over root 5. That would give me root 10 over 5. Now, can I simplify root 10 any further? No, so I'm just going to leave it as, and that doesn't look like a 5, so I'll just change it, root 10 over 5. Let's write that, root 10 over 5. And then this next one's slightly trickier because it's got 2 terms on the top, but we still do exactly the same. So we multiply both the top and the bottom by roots, by whatever the denominator is, in this case root 6. So let's try this up here. So I've got root 6 multiplied by 2, take root 5 over 6. Now let's expand the brackets. So that would become 2 root 6, take away 5 times 6 is 30 over 6. Now if this is confusing you, watch the video on expanding surds to single brackets. If not, let's continue. So we're always trying to simplify. So over here, let's see how I can simplify root 6. I could write that as root 3 times root 2, which I can't simplify. So actually that is simplified in its furthest form. And root 30, what square numbers can fit into 30? 4, 16, 30. I don't think any can. 5 times 6, 10 times 3. Nope. So that is it. That is how you leave that. You can't simplify it any further. So that's your final answer. So the key thing is, some of you might be like, that makes it look more confusing. Yeah, perhaps. But the point is that we're rationalizing the denominator. So the denominator is a rational number. Okay, next we've got something that has two terms on the bottom, and what we have to do in this case is find the conjugate, which essentially means the same terms just with a different sign in the middle. So let's see how that works. That goes root 7 times take 3. Now just think back to when you expand brackets. So if you expand brackets and you have, let's say, I don't know, x plus 4, x take 4, what happens? You get x squared take 4x plus 4x take 16. So the key thing is that the two middle terms cancel out. So that's why we use the conjugate, because when we expand the double brackets, the middle terms are going to cancel out. And so we would have got rid of the third part. So let's see this in action. We're going to multiply that by root 7 plus 3. So the conjugate is literally the same terms, just switch the sign. So multiply by root 7 plus 3. That would give me 6 brackets root 7 plus 3. And then over here, root 7 take 3, root 7 plus 3. Now, if this is a little bit confusing, once again, watch the video on expanding double brackets with surds. But we're just going to go full steam ahead. So that would become 6 root 7 plus 6 times 3, which is 18. And then let's expand the double bracket up here. So root 7 take 3, root 7 plus 3. Root 7 times root 7 is just going to be 7. Root 7 times 3 is going to be 3 root 7, negative 3 root 7, and minus 3 plus 3 times 3 is negative 9. So the key thing is that these two terms are going to cancel out because they're like terms. It's just one is positive, one is negative. So I'd just be left with 7 take 9, which is negative 2. So I would be left with negative 6 root 7 plus 18 over 2. Not the nicest looking thing, but that's all you do. So let's have a go at one more. We've got 3 plus root 2 over 5 take root 2, and remember, all we do is we multiply by the conjugate. So in this case, it's going to be 5 plus root 2 over 5 plus root 2. So annoyingly, we're going to end up with double brackets on both the numerator and the denominator, but hey, what can we do? So that would become 3 plus root 2 over 5 plus root 2 over 5 take root 2, 5 plus root 2. So let's do the top bracket first. So 3 times 5 is 15. 3 times root 2 would be 3 root 2. Root 2 times 5 would be 5 root 2. And root 2 times root 2 is just going to be 2. And I can see already how I'm going to simplify that. But let's do the denominator. So 5 times 5 is 25 plus 5 root 2. Take 5 root 2, take 2. Okay, so now let's simplify them bit by bit. So over here, these two terms can simplify. So 15 plus 2 is 17. And then 3 root 2 plus 5 root 2 is 8 root 2. Then we've got 25 take 2, which is 23. And 5 root 2 take 5 root 2 cancels out. So that's it. So I could have done that more central, really. But that's how we do that. So multiply by the conjugate. And the key thing is that the bottom terms, when we do that, they cancel out. So to finish it off, let's have a go at these questions by yourself. Pause the video and let's see how you get on. Okay, so first we would multiply by 2 take root 5. And let's see what happens there. So I'd be left with 3 brackets 2 take root 5 and 2 plus root 5 2, take root 5. So let's do it step by step. The top bracket would end up being 6, take 3 root 5. And over here, 2 times 2 is 4. 2 times negative root 5 would be negative 2 root 5 plus 2 root 5, and then take 5. So these two terms would simplify, and I'd just be left with 6 take 3 root 5, and 4 take 1 is negative 1, so that would become a negative. So minus 6 take 3 root 5 over 1. Okay, oops, I wrote that in the wrong answer box. Okay, so or just negative 6 root 5 and just flip the fractions. So then we've got this question here, so we just multiply by the denominator. So root 5 take root 3 times root 5 take root 3. So that would become root 5 take root 3 multiplied by root 5 take root 3 over root 5 plus root 3 multiplied by root 5 take root 3. So let's do the numerator first. Root 5 times root 5 is going to give you 5. Root 5 times negative root 3 is going to be negative root 15. And negative root 15 again. And then plus 9. Over root 5 times root 5 would be 5. Take 3 root 5. Or, oh, I didn't write the square number. Sorry. That needs to be in a square. So that would be take root 15 plus root 15 and then take 3. So let's simplify even further. We'd have 5 plus 9 is 14. We've got 2 lots of root 15, so it'd be 2 root 15. These two cancel out, and 5 take 3 is 2. So my answer here would be 14 take 2 root 15 over 2. And with our last question, this one's even trickier because it's got surds that have a coefficient, but let's just give it a go. So we're going to multiply by 3 plus take 3 root 2, the conjugate, and 3 take 3 root 2 over here. So that would become this lovely looking double bracket of this, and 3 plus 3 root 2 multiplied by 3 take 3 root 2. Okay, so let's do it one step at a time. So let's do the numerator. We've got 7 times 3 would be 21. 7 times by 3 root 2 would be negative 21 root 2. Then we've got negative 6 root 8. And then we've got plus 2 times 3 is 6. And root 8 times root 2 is going to be root 16. So we'll deal with simplifying that in a bit. Then we've got 3 times 3 is 9. 3 times 3 root 2 is going to be 9 root 2 plus 9 root 2. And then take away 9 root 4. So what can we simplify first? Well, this is in its simplest form already. This I can simplify, and this I can simplify. So 6 root 8 could become 6 times root 4 times root 2. Root 4 is 2, so that would become 12 root 2. And then root 16 is just 4, so that would become 6 times 4, which is 24. So that would become 21 plus 24, which would be 45. So 21 plus 24 is 45. And then take away 21 root 2 plus 12 root 2, because that's written as 12 root 2. So minus 21 plus 12 would become negative 9 root 2. So I've simplified the top, and then over here we know the middle two terms are going to cancel out, and 9 times root 4 is 18, because 9 times 2 is 18. So 9 take away 18 is, hold on a second, yeah, 9 take away 18 is -9, so once again the whole thing becomes negative. So that's how you do that. Now, I did make these questions quite quickly, so normally they're not going to be a negative number on your denominator, but should they be, then you just whack a negative sign in front of it. Okay, hope you enjoyed the video, and let me know if you want any further questions, any trickier questions, or any clarification.